Hey Geography 211, sorry we're not able to do this in person, but hopefully this video is some help for you in learning how to set up a weather station. Before we head out into the field, the first thing we'd always do is do a field activity plan. This is all about planning, recognising what we need to do to keep ourselves safe in the field. The most important part of that is hazard identification and control. We're not going to go through this in a lot of detail just now, but we'll consider our site and have a bit of a look, see if we can see any hazards. So fairly open field, not too much of a problem, not too many overhead hazards. Hang on, what's that? It's looking pretty vicious. It's attacking something. Oh no, it's fuzzy. Oh, it's just my puppy Digby. Hello Digby, how you doing? I was doing just fine till you came and wrecked everything with your stupid dad jokes. Right, we better have a look at this properly now. So, thinking about what sort of safety gear we might need. We've got a bit of uneven ground there. Good thing I got my boots on. Always good to have decent boots. And we've got a pile of other safety gear, so let's have a look through and see what would be needed for today. Nice and sunny out, so sunscreen's always a good idea. Definitely keep that. We don't have too many other workers around or machinery, so I can do without the high-vis vest in this situation. I'm getting a bit bored, so sun hat's a good idea. I can also be a bit accident prone, but even if I wasn't, we've got the dog around, all sorts of other things can happen, so first aid kit's a must. Safety glasses, don't have any here, don't really need them, but it is sunny, so we'll sit with the sunnies. Not using any heavy machinery, drills, or doing any hammering, so I can do without the earmuffs. Gloves could be handy. Do we need a helmet of any kind? Let's have a think. What's our area like again? Not too much in the way of overhead hazards. So I think for today we can do without a helmet. And that just leaves... might hang on to that for other reasons. Let's hope we don't need it. But not for today anyway. So safety gear sorted, let's move on to the bits and pieces we need for the weather station. We've got our tripod there all folded up and a few brackets. Grabbed most of this in a bit of a hurry, so we'll just have to see as we go if we need to be inventive. A magic box, which has hopefully got some useful bits and pieces in it, and a solar panel there to keep everything charged. So let's crack open the magic box and see if we've got all the sensors and bits we need to make our recordings. This is looking promising. So we've got some weight things. Let's see if we can figure out what these are. Cables attached, always a good start. Young, they make some good stuff. Got a good reputation for wind measurements. And on the other side here we can see that it's a weather transmitter. SDI12 tells us that it's a smart sensor. It's going to be sending serial data. And we've got two of these, one for an upper measurement, one for a lower measurement. So while I just grab these brackets out, talk a little bit more about those young sensors. They are two-dimensional sonic anemometers, so they measure wind speed and direction. They also have some other electronics in there for measuring temperature, humidity, and barometric pressure. So getting a lot of information out of each of those instruments. Next we have this little puppy, Apogee. So this is an Apogee SN500. We've just knocked one of the caps off there, so I'll take the rest off. So this is actually 4 instruments in one, effectively. We've got incoming and outgoing solar radiation and long wave radiation. So this gives you your whole radiation balance all in one handy instrument. We want to make sure that we protect those sensors when they're not being used. So I'll put those lower caps on for now. And we've got the mounting arm, which will pop in there. And we want to make sure that we've got the right cable for it. We'll just move the logger box and check and make sure that this is going to be the right kind of cable. So some quite delicate pins there, so you've got to be quite careful when you're connecting this up, but that is the right one, so we're off to a good start. So that's the bottom of the logger box. You can see that there was a number of plugs there. That's the earthing cable. Inside we've got various components. As you can see, there's been a fair amount of pre-wiring done, so that's there to speed things up in the field. So the heart of the system here is made by a company called Campbell Scientific. That's the data logger. So we program the data logger so it knows what measurements it's taking from which ports. And of course also we need to power the system, so we've got a lithium battery there. It's a lithium iron phosphate battery, which is nice and stable and pretty secure. And these are the pre-wired plugs which match up with these sockets. So we've got some labels there: Y for young, A for apogee, S for solar, and G for ground. So hopefully that'll help us when we come to plug that up later on. So now we're all set to go. Got my hat, got my sunnies, got my gloves. Let's get into it. So the gloves are really good for these types of setups. These guy ropes that we'll be setting out shortly are made of steel wire, stainless steel wire, so they can have sharp bits sometimes, so gloves are good. There's all these moving parts as well that fingers can get caught in, so another reason for having the gloves on. So each of these legs has got two sets of guys. The first set connect in at the bottom, and once that first set is connected in, the structure will hold itself fairly well in place. So this is a really nice flexible design, and as you can see, I move it around nice and easily because it's all made of aluminium except those fittings that we mentioned. Now the second set of guys going from the tops of the legs to the centre of the pole help with stability, and particularly good if it's nice and windy. We've got some turnbuckles on there which we use for adjusting the level, get things as straight as we possibly can. It's not always possible to get it exactly right. The system is designed to be fast and easy to deploy, so not as robust as some other systems. So now we'll put in our centre pole and we'll get an idea of the height, and we can decide where we're going to put it. Let's try over here. So, in under the tree, not so good for wind. Over by the fence, well, be good if we wanted to know what was happening with the grapes maybe, but we want a general picture of what the weather is in this location. So as far open as we can get it, it's not great, but it'll be good enough. We often have to compromise. If wind was our specific measurement objective here, then this location wouldn't be suitable. So as we add our top sensor on, it's handy to be able to pull out that major pole because I'm not quite tall enough. And we need to make sure that we're aligned with north, so we know what our wind directions really mean. So we need a way to measure where north is. So of course a compass is a good idea, but also if you've got a smartphone on hand, there's a number of apps available with compass measurements, and you've got to be a little bit cautious about getting too close to metallic objects, either with the compass or with your smartphone, because the metal may interfere with the measurement. You want to line yourself up, make sure if you're thinking about true or magnetic north. Once you've got yourself aligned, pick a reference point that you can refer back to quickly and easily as you're doing the rest of your setup. Make sure you know where your north point is before you slot it back in. You're going to have to check this a few times at various different stages. So that's why having that reference point is certainly a useful thing to go back to from time to time. Make sure you're still correctly aligned. Okay, now we've got our second wind sensor to put on. Uh-oh, where's our lower bracket? So, as I kind of mentioned earlier, it's this stuff was grabbed in a bit of a hurry, so I didn't have time to check everything fully. So oftentimes you'll get out in the field and discover there's a bit of a problem. Hopefully you've done proper preparation, done a full test setup so you don't have that situation occur. But if you're out there, especially if you're a long way away, sometimes you've got to get inventive and make some adaptations to what you've got. Here I'm undoing a bracket from another pole which someone's over tightened, so it seems a bit counterintuitive, but sometimes over tightening can be as much of a problem as under tightening, especially with an aluminium system like this. If you over tighten it, then you can actually start damaging the pole, which we might possibly see some evidence of a little bit later on. The other slight downside of this little adaptation that I'm making here is that the lower sensor is going to end up a little bit higher than we would perhaps hope. We wanted to get it as close as we could to the ground, but it's going to be up a little bit higher. We'll do some measurements later and confirm what that is. So now with that improvised bracket in place, we can start tightening up the rest of our turnbuckles on the main pole and start thinking about our level. Make sure we're up and down nice and vertically in both directions, which is not as critical as it would be with some other types of systems. So the sensors that we're using, being two-dimensional sonics, are not as susceptible to providing errors if they're slightly off level. So again, we can use an app on our smartphone. Analog level bubbles are probably better, but for convenience, smartphone apps are usually quite good. So just tweaking those turnbuckles until we're nice and snug and also nice and vertical. Now it's time to put that last young sensor on, and again we need to make sure that this is facing in the same direction as well, so that any differences we see are true differences. The other thing that we want to do is we also want to make sure that that alignment isn't going to change. So we check to make sure it's good, and then we've got some little tightening screws that we can tighten up to make sure that they're not going to change. And if any of you are easily scared, then look away now. There's about to be some exposed flesh. No! Turn away! The horror. That's alright. So, now we need to start thinking about adding on our net radiometer. So we've got a bracket already on the tripod, just loosening that off, and if anyone was watching closely, you may have noticed something happened there. That was what I was mentioning earlier with problems with over tightening. One of the advantages of this bracket is that it has a nice levelling system built in, so the net radiometers have a fairly wide field of view, but if that's offline and it's looking anything other than level, then that can introduce some errors that don't need to be there. So I look at the level bubble on top of the instrument, and then we can use the adjusting screws to get the instrument nice and level. Now that we've done the bulk of the big work, we can take the gloves off for some more delicate stuff. Aligning up this small delicate cable, plugging that in. We often wrap the cables around to reduce them flapping in the wind, and we'll often use cable ties or electrical tape. We also want to make sure that we're packing things away as we go so we don't lose critical little elements. And we also want to be packing away our rubbish as well, because we don't want to leave that in the environment. So now we've got to mount our data logger. So this is just using a saddle clamp or U-bolt, various different names for them, which have been used on a number of these other mounting points as well. So it's always good when you're doing screws on and also screwing up cables, just to be careful not to force things. You want to make sure that the alignment is good, take your time, and when you're tightening things up you want to get them nice and firm but not over cranked. So let's go in and have a bit of a look and see how everything is so far. So there's our Apogee net radiometer, cables in place, and there's the level bubble, a little bit hard to see but pretty close to the centre there, reasonably good. Our lower young anemometer, let's have a look for that north point. It's hiding down in there, lined up to our reference point that we sighted with our compass earlier, and then the upper one is also aligned nicely. One more element to mount on the tripod, and that's our solar panel. It's a little bit tricky mounting solar panels when you've got net radiometers. If you have them too low, then they can block the view. If you have them above, they can cause shadowing. So it can be a little bit tricky getting that quite right, and there's not often a perfect solution. But actually in this situation we've got a fairly good solution provided by our improvised bracket. Having it off to the side like this is still going to have a teeny bit of an impact, but a lot better than most other solutions. So let's mount that up. It's worthwhile noting that this is fairly much directly below the lower temperature sensor, so there's a small chance of some impact on that temperature reading, but hopefully not too bad, given that these have got good quality solar radiation shields, so they're fairly well protected from most sun angles. So solar radiation shields are there to reduce solar loading and give you a more true indication of actual air temperature. So now let's zoom in and have a look inside the data logger box and get things working. So of course, before we kick things off, we need to have some power available. So it's good that we've got some electrical tape on there. It's an important safety aspect when we're transporting these, in case anything bridges across the terminals. We don't want any shorting out. So to provide power to the system, we're going to match up our colours, so red to red, so that's our positive side, and then in this case it's blue to black, that's our negative side, and then we can use that tape just to hold those on nice and securely. So that cable's going up into our solar regulator box, which basically controls the whole flow of power throughout the whole little system. So the battery light is showing that things are okay. It's pretty dull to reduce power, so that's all good. And now we need to put in our solar power. So you can see with this cable that it's not pre-wired, so as we're going through the process of getting this set up, you'll see why we go through the process of pre-wiring. As we're actually unwrapping the solar panel cable, you'll see that the wires are wrapped up separately. The reason for that is that if we get light on the solar panel and those wires are touching, then the energy that's being output from the solar panel will short across the cables and do potential damage to our solar panel, which we don't want. So while we're working with our cable, we try and get those separated. So we're going to be using this thing called a cable gland to keep our enclosure nice and waterproof, and we've got a little rubber boot there that goes over things. So we've got to put those on, let it slide down, and then we can feed it up into the logger system. Start pulling it through. Now we've got our cables available. We can wire these into our regulator. So it seems slightly odd, but the brown cable on here is the positive. Often giving them a little bit of a twist will just help get them into the slots. In this case, they've been tightened up a little bit, so we just need to loosen them off before those cables will go in. The regulator's fairly well labelled, so it's fairly easy to figure out what's supposed to go where, but it's always good to double check these things, because if you get your power cross-wired, then that can cause damage to your system and cost you a lot of money. To give you an idea of cost, the data logger that's in the system is worth close to $2,000. There are other data loggers that are worth a lot more. Now that we've got that solar panel in, we've got our power going, and that's charging up the system, and we can pop that back in place, which is with some adhesive velcro that we've got in there. And now we're ready to power up the system after we plug some more sensors in. So that's just tightening up the cable gland that we put on before and let it slide up the cable. Now we want to plug in the rest of our sensors. We need to make sure that they align properly. They've got an alignment point, so we look for that, then look for where it matches up on the appropriate plug underneath, and that means all our wires are going to be going in the right place. Checking that with each one as we plug them in. So we've got two different Youngs. Actually with this system it doesn't matter which one gets plugged in where, which is just a neat little trick of the way the pre-wiring in the program has been done, and also the way SDI 12 works. And then our last one is our Apogee, which is on our A plug. So these are weatherproof plugs. Really good if you're in cold environments. You don't want to be fiddling around with all those loose cables. And now we're ready to plug our power in. And just checking to see that the logger's behaving itself. There we've got a little bit of a flash showing us that the power's going okay. We've got a network port there and a USB port. We're going to be using the USB port. This one's a micro USB. So now onto the software side of things. We're going to be using loggerNet, which is made by Campbell Scientific. USB goes into the laptop and the micro USB up into the logger. loggerNet's a very powerful program. It can do all sorts of different things. We're going to keep it fairly simple for today and go straight into the Connect screen. On our left hand side we've got a whole lot of stations that we can choose from. A station is basically just a set of communication instructions and settings, so we know we can connect to the right type of logger and record our information in the right locations. There's a number of things that we can do with those stations, but for now we're just going to do a direct connection. So click connect button and our times come up, and we've got our little connected symbol showing how long we've been connected. We know we're all good. The next step we want to do is just reset our time to make sure that we're synchronized nicely. Now we can have a look and see if we're getting some sensible numbers. So we've got a drop down menu here, and the public list is all the different things that are being measured in this particular program. So we can scroll down through and make sure that our current readings are what we're expecting. And here we have values from our net radiometer. And one of the cool advantages with the system being nice and low down to the ground is we can actually monitor the values as they change. If we put our hands over the sensor, see if the values drop down, you'll notice they don't change instantly. This is running at a 5-second execution rate, so every 5 seconds it's running through the program and taking measurements. But as we block our hands over, you'll see that the short wave goes down and the long wave actually goes up. So the long wave is actually receiving heat from our hands, so that's changing the values there as well. There's a number of other different things that we can do. We can have numeric displays of specific values if we want to monitor how they're going, and we can also set up graphs, which is quite useful for making sure that things are trending in the right direction while you're still at the station, to check things behaving themselves. So let's try and bring up a graph, and for a start we're going to add in some values. Right click over here and we can go to add, choose from the public list, and we're going to choose our 3 different temperature sensors. We've got the panel temperature, and we've got the upper and lower air temperatures from those young sensors. So I'll add those in. And then we can close up our dialog and make our screen a bit bigger so we can watch things evolve on the graph. Now, one of the things to be aware of with this is that the scale on these are dynamic, so unless you change the configuration, so we can see at the top here we've got our panel temperature is quite a bit higher than our other 2 temperatures. That's because the logger itself generates a little bit of warmth, and also it's not in a solar radiation shield, so those values are looking fine. What about our wind sensors? Let's have a look and see if we're getting any difference between our 2 different wind sensors. So put another graph together. So what we would hopefully expect to see generally is that our upper wind speed would be, what do you reckon, higher or lower? Generally speaking, our upper one should be a higher wind speed. That's not always going to be the case. Well, let's have a look and see what's happening with ours. So although ours are listed as upper and lower, there's only about a metre, just a little bit over a metre separation between the two, so not a huge difference. So we would expect from time to time them swap around which is higher and which is lower, both because they're not too much difference in height, but also because of the way turbulence works, and our lower sensor is actually a little bit blocked by where our logger is as well, so we may be getting some wind currents going around there. So all little things just to keep in mind. So there's a number of other things that we can look at while we're in here. We talked about the public list, which is all the measured values. At the moment we're looking at the wind quality value, so that's just a check on the sonic anemometer if it's getting good quality signal. We can also have a look at the status of the logger, which tells us how its memory is, all sorts of different things about its deployment history, software, and so on. And then we can also look at the recorded 10-minute data. So even though it's taking measurements every 5 seconds, it's only doing a series of recordings every 10 minutes, which is typical for a general weather monitoring type station. So all in all, things are looking pretty good. So we can now disconnect, and the logger should continue on its happy way, recording information for us. And now we can unplug our cable and start picking things up.